I've solved a bunch of problems from chapter 5 and I've posted these solutions up there. And what I'll do in these videos is just walk you through what I did. So this is fundamental problem 5.3 and I've drawn the free body diagram right here. Remember, you always have to draw the free body diagram. And what I did to draw that free body diagram was I made a loop like this, but I did it mentally. I looked in there, I drew everything in there, and I made sure to draw that 5 kilonewton, which is perpendicular to the truss at point C, this 10 kilonewton load there. Then the next step was then I drew everything I cut through, and you can see that I cut through a pin there, and so that meant I got two reactions right there at A, and I cut through a roller right here at B, and that means perpendicular to the surface or the ground, which is going straight up perpendicular to the ground, I had one reaction. And once you have the free body diagram, these 2D problems are always the same. You have three equations: sum fx equals 0, sum fy equals 0, and some moment about some point. I did the x direction first because I noticed there was just one unknown in the x direction, Rax. So I just looked at the free body diagram picture and I took everything going horizontal. So there's the Rax plus that 5, the horizontal component, that was 45 degrees, so 5 cosine 45 degrees equals 0. And I just solved that for Rax, which gave me Rax is minus 3.54. So when I solve this equation here, I got a negative number, which means the original assumption, Rax to the right, was incorrect. So the correct answer is 3.54 kilonewtons to the left. I like you to always draw in parentheses the actual direction. Next, I wanted to get RBY, and I noticed there were two reactions at A, so I decided to take moments about A. Taking moments about A, what I did was I assumed that this 5 kilonewton force from the picture was perpendicular to the truss, and so the perpendicular distance from A to that 5 kilonewton force was drawn right in there. It was 4 meters. So taking moments around A, I got 5 times 4. That's the 5 kilonewton force times the 4 meter distance. And then I needed to get this 10 kilonewton force times its perpendicular distance, and that distance was right here. It was the horizontal component of 6 meters at a 45 degree incline, so that's this 6 cosine 45 degrees, and then another 2 meters if you look at this picture right here. So let me draw it in here. This is 6 cosine 45 degrees. Right here, this much, and then this little bit extra here was 2 meters, this much right there. Okay, then I had RBY, and its distance away from A was again 6 cosine 45 degrees, and then another 6 meters. So this is the force, and this is the perpendicular distance. And solving all that for RBY, I got RBY is 8.05 kilonewtons. Then once I knew RBY, the only other y unknown was RAY, so then I just sum forces in the y direction. Coming down, you have the y component of that 5 kilonewtons, so 5 sine 45 degrees or 5 cosine 45 degrees, the same thing. You've got that 10 kilonewton force coming down, so both of those are negative. We just solved for that reaction at B going up, 8.05 kilonewtons, and the unknown RAY. And solving that for RAY, we get 5.49 kilonewtons going up. Well, the geometry was complicated enough that I was not sure of myself, so I decided to check. Take moments about some other point, and so I'm going to take moments about point C, where that 5 kilonewton force is, just because then I don't have to do x and y components of that. I wanted to see if the moments at C add up to 0, which they should. So 3.54, which was let me double check that. 3.54 That was 4 cosine 45 degrees. RAY. So let me find RAY. Oh, let me double check. Just 1 second. Okay, 3.54 was actually RAX. Okay, so we have RAX 3.54 going to the left, taking moments about C. The vertical distance, which is a perpendicular distance to RAX, is 4 cosine 45 degrees. Then RAY, which is 5.49, it has a horizontal distance because it's vertical. The perpendicular distance is horizontal of 4 times sine 45 degrees. So here we go right here. This was RAX, this was RAY, and this was the perpendicular distance from that reaction, and this was the also the perpendicular distance from the reaction. Okay, so again, this reaction is going that way, and that distance there is 4 cosine 45 degrees. This reaction is going that way, and this distance is 4 sine 45 degrees. Then you have that 10 kilonewton force going down. Its perpendicular distance, horizontal distance from point C is 2 cosine 45 degrees and an extra 2 meters. And then the reaction at B we calculated to be 8.05, and its distance again was 2 cosine 45 degrees and another 6 meters past that. I added that all up and it came out to 0.002, which is 0. That it should be 0, but because of round off we don't get exactly 0. So I'm very confident that these answers are correct.